Compact fluorescent lamps, or CFLs, are electronic devices designed to regulate the power supply to fluorescent bulbs, enabling them to start and operate efficiently. A crucial aspect to understand is why standard wall switch timers and CFL often don't mix well. The electronic components within CFL ballasts can generate significant inrush currents, also known as surges, when power is initially applied. These inrush currents can be several times higher than the steady-state operating current of the bulb. Standard wall switch timers are not typically designed to handle these high inrush currents. Consequently, using them with CFL can lead to damage or a significantly shortened lifespan for the timer. Many fluorescent bulbs, often referred to as CFL, function on a smaller scale. They commonly incorporate a built-in ballast within the bulb base, eliminating the need for separate ballasts. When using mini fluorescent bulbs with wall switch timers, there are several key considerations. Firstly, check the timer's compatibility. Certain wall switch timers are specifically designed and rated for use with CFL. Always consult the manufacturer's instructions or contact them directly for clarification regarding compatibility. Secondly, consider using lower wattage bulbs. Opting for CFL bulbs with lower wattage ratings, such as 13 or 18 watts, can effectively reduce the inrush current. This makes them more compatible with standard switch timers that might not be designed for higher loads. Thirdly, if the wall switch timer you currently have is not compatible with CFL, it is advisable to purchase a dedicated CFL-compatible timer. These timers are engineered to withstand the higher inrush currents produced by CFL. It is important to understand the potential damage that can occur if high inrush currents are applied to a wall switch timer not designed for them. This can result in several adverse effects. Firstly, overload and blown fuses. The excessive current draw during startup can overload the timer's internal circuitry, causing fuses to blow and disrupting the circuit. Secondly, short circuits. The inrush current can damage the timer's components, leading to short circuits and potentially hazardous situations. Thirdly, premature failure of the timer. Even if the timer doesn't immediately fail, repeated exposure to high inrush currents can weaken its components, leading to premature failure and the need for replacement. To ensure safe and reliable operation of both your lighting and your wall switch timer, firstly, always refer to the manufacturer's specifications for both the timer and the CFL bulbs. This will provide you with crucial information about compatibility and any limitations. Secondly, consider the total wattage of the CFL bulbs being controlled by the timer. Ensure that the total wattage does not exceed the timer's rated capacity. Overloading the timer can lead to overheating and potential failure. Thirdly, look for timers specifically designed for use with electronic ballast. These timers incorporate features such as zero-crossing switching, which minimizes inrush current and protects the timer from damage. Fourthly, if you are unsure about compatibility, consult a qualified electrician. They can assess your specific situation and recommend the appropriate timer and lighting options. Fifthly, inspect the wiring connections to the timer. Ensure that all connections are secure and properly insulated. Loose or faulty connections can create resistance, leading to heat buildup and potential fire hazards. Sixthly, consider using LED bulbs as an alternative to CFL. LED bulbs typically draw less power and produce less heat than CFL, making them a more energy efficient and safer option for use with wall switch timers. Seventhly, if you experience any problems with your wall switch timer, such as flickering lights or the timer failing to operate correctly, immediately disconnect the power and investigate the issue. Do not attempt to repair the timer yourself unless you are a qualified electrician. Eighthly, regularly inspect your wall switch timers for any signs of wear or damage. Look for cracks, discoloration, or loose components. Replace any damaged timers immediately to prevent potential hazards. Ninthly, when replacing a wall switch timer, choose a model that is compatible with the type of lighting you are using. There are timers specifically designed for incandescent, fluorescent, and LED lighting. Tenthly, consider using a smart timer that can be controlled remotely. Smart timers often offer features such as dimming and scheduling, allowing you to customize your lighting to your specific needs. In addition to the above points, it is also important to understand the basic principles of electrical circuits. Electricity flows through a circuit like water flows through a pipe. Voltage is the electrical pressure that pushes the current through the circuit, measured in volts. Current is the rate of flow of electrical charge, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Mathematically, this is expressed as voltage equals current times resistance, or volts equals amps times ohms. When a CFL is first turned on, the ballast needs to charge up the capacitors within the bulb. This charging process creates a large inrush current that can overwhelm a standard wall switch timer. The timer's contacts may not be able to handle the high current, leading to damage or failure. Dedicated CFL-compatible timers are designed with robust contacts that can withstand these inrush currents. They may also incorporate surge protection circuitry to further protect the timer from damage. When selecting a CFL-compatible timer, pay attention to the timer's specifications. Look for a timer that is specifically rated for use with electronic ballasts. The timer should also have a high inrush current rating. This rating indicates the maximum current that the timer can safely handle. It is also important to consider the total wattage of the CFL bulbs that you will be controlling with the timer. The timer should be rated for at least the total wattage of the bulbs. For example, if you are controlling 4 13-watt CFL bulbs, the timer should be rated for at least 52 watts. If you are unsure about the compatibility of a timer with your CFL bulbs, consult a qualified electrician. They can help you select the right timer for your application. In addition to CFL, LED bulbs are also becoming increasingly popular for energy-efficient lighting. LED bulbs typically draw less power than CFL and have a longer lifespan. However, some LED bulbs can also generate inrush currents when they are first turned on. If you are using LED bulbs with a wall switch timer, it is important to check the timer's compatibility with LED bulbs. Some timers are specifically designed for use with LED bulbs, while others may not be compatible. When selecting a timer for use with LED bulbs, look for a timer that is rated for use with solid-state lighting. The timer should also have a high inrush current rating. The National Electrical Code, or NEC, provides guidelines for the safe installation and operation of electrical equipment. The NEC is updated every 3 years, so it is important to stay up to date with the latest requirements. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. When installing a wall switch timer, it is important to follow the NEC requirements. This will help ensure that the installation is safe and compliant with local regulations. Some specific NEC requirements that may be relevant to wall switch timer installations include: firstly, conductor sizing. The conductors used to wire the timer must be sized appropriately for the load. The NEC provides tables that specify the minimum conductor size for different amperage ratings. Secondly, overcurrent protection. The circuit supplying the timer must be protected by an overcurrent device, such as a circuit breaker or fuse. The overcurrent device should be sized appropriately for the load. Thirdly, grounding. The timer must be properly grounded to protect against electrical shock. The NEC specifies the requirements for grounding electrical equipment. Fourthly, box fill. The electrical box housing the timer must be large enough to accommodate the conductors and devices. The NEC specifies the maximum number of conductors and devices that can be installed in an electrical box. Fifthly, wiring methods. The wiring methods used to connect the timer must comply with the NEC requirements. The NEC specifies the types of wiring methods that are permitted for different applications. By following the NEC requirements, you can ensure that your wall switch timer installation is safe and compliant with local regulations. It is always recommended to consult a qualified electrician if you have any questions or concerns about electrical installations. They have the knowledge and experience to ensure that the work is done safely and correctly. When working with electricity, it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. They can ensure that the work is done safely and correctly. Electrical safety is essential for protecting yourself and your property from electrical hazards. By following the NEC requirements and taking precautions when working with electricity, you can minimize the risk of electrical shock and fire. Remember to always consult a qualified electrician if you have any questions or concerns about electrical installations. When dealing with electrical components and installations, understanding the relevant terminology is crucial. Here are some key terms to be familiar with. Firstly, amperage. Amperage is the measure of electrical current flowing through a circuit measured in amps. It represents the rate at which electrical charge is moving. Secondly, voltage. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. It represents the force that drives the current through the circuit. Thirdly, wattage. Wattage is the measure of electrical power calculated by multiplying voltage by amperage. It represents the rate at which electrical energy is being used. Fourthly, ohms. Ohms are the unit of electrical resistance representing the opposition to the flow of current in a circuit. Fifthly, ballast. A ballast is a device used to regulate the voltage and current supplied to a fluorescent lamp or other gas discharge lamp. Sixthly, inrush current. Inrush current is the high initial current that flows when an electrical device is first turned on before it reaches its steady-state operating current. Seventhly, circuit breaker. A circuit breaker is an electrical safety device that automatically interrupts the flow of current in a circuit if it exceeds a safe level. Eighthly, fuse. A fuse is another type of electrical safety device that contains a metal wire that melts and breaks a circuit if the current exceeds a safe level. Ninthly, grounding. Grounding is the process of connecting an electrical circuit or device to the earth, providing a path for fault current to flow and preventing electrical shock. 10thly, National Electrical Code. The National Electrical Code, or NEC, is a set of standards and guidelines for the safe installation and operation of electrical equipment in the United States. Understanding these terms will help you better comprehend electrical concepts and ensure safe electrical practices. Always consult with a qualified electrician if you have any questions or concerns about electrical work. They can provide expert guidance and ensure that your electrical systems are safe and compliant with all applicable codes and regulations. Staying informed and prioritizing safety are essential when working with electricity. It is also good to know about other types of lighting systems besides the compact fluorescent lamps. Firstly, incandescent lighting. Incandescent lighting uses a filament that is heated until it glows, producing light. This type of lighting is less energy efficient than CFL and LED and has a shorter lifespan. Secondly, halogen lighting. Halogen lighting is similar to incandescent lighting but uses a halogen gas to increase its efficiency and lifespan. Halogen bulbs are brighter than incandescent bulbs but still less energy efficient than CFL and LED. Thirdly, light-emitting diode or LED lighting. LED lighting uses semiconductors to produce light. LED are highly energy efficient, have a long lifespan, and come in a variety of colors and brightness levels. Fourthly, fluorescent lighting. Fluorescent lighting uses a gas discharge to produce light. Fluorescent bulbs are more energy efficient than incandescent bulbs but less energy efficient than LED. They also contain mercury, which requires special disposal procedures. Each of these lighting types has its own advantages and disadvantages, and the best choice for a particular application depends on factors such as energy efficiency, lifespan, brightness, color, and cost. When selecting lighting for your home or business, it is important to consider all of these factors to make the best decision for your needs. In addition to the types of lighting, there are also different types of lighting controls. Firstly, standard switches. Standard switches are simple on-off switches that control the flow of electricity to a light fixture. Secondly, dimmer switches. Dimmer switches allow you to adjust the brightness of a light fixture. They are commonly used with incandescent and halogen bulbs, but can also be used with some CFL and LED. Thirdly, timers. Timers automatically turn lights on and off at preset times. They can be used to save energy and provide security. Fourthly, motion sensors. Motion sensors turn lights on when motion is detected. They are commonly used in outdoor lighting to provide security and deter intruders. Fifthly, smart lighting controls. Smart lighting controls allow you to control your lights from your smartphone or other device. They can be used to create custom lighting scenes, schedule lights to turn on and off automatically, and monitor energy usage. When choosing lighting controls, it is important to consider your needs and preferences. Do you want to be able to adjust the brightness of your lights, or do you simply need to turn them on and off? Do you want to save energy, or do you want to provide security? By considering these factors, you can choose the right lighting controls for your home or business. Remember that working with electricity can be dangerous, so it is always best to consult a qualified electrician if you have any questions or concerns. They can help you choose the right lighting and lighting controls for your needs and ensure that they are installed safely and correctly.